Tero Parviainen. So another big round of applause.
All right, hello. So yeah, let's get through this. So how many people actually here use JavaScript frameworks such as Angular or Ember? Over half of everyone. Okay. How many people like using JavaScript frameworks? I think it was a bit more than the first question. That's interesting. So I'm a JavaScript application developer and I use JavaScript frameworks. And the thing is though that I'm slightly afraid of frameworks as well, because they seem to be these huge things that are difficult to approach, they're kind of hard to learn. They have so much stuff in them that it's like intimidating when you are faced with the task of picking up a framework. And the last time I was facing this fear of mine was last year when I was looking at what I should use for the next big JavaScript project. And I was looking at this current crop of popular JavaScript frameworks, and they are large frameworks. Like Angular has 13K lines of non-test code spread over almost 100 files. Ember has almost 20K lines of non-test code, and that's not yet including Ember data. So these are big things. They're not big as in Java scale big, but given the expressiveness of the JavaScript language, they are quite large. You can do a lot in 13,000 lines of JavaScript, and Angular in fact does do a lot. So that made me think, how can I? Well, we chose to use Angular for the project, and then I was facing the question of how can I pick Angular up then and actually learn it and be effective with it. So I think there are at least 3 different strategies for that you can employ when facing a question like this. The first of them is probably the most easy to begin with, and that is to say that I'm just not going to, these frameworks are too big. Angular is too big for the problem I'm trying to solve, or Ember is too big. So I'm just not going to spend that effort. I'll use simple tools, simple libraries, and come up with my own simple framework for solving my own problem. And last year, it wasn't the case yet, but now it seems to be that this strategy is almost synonymous with React. So I'll use that as an example of this approach. So React is often said to be like a alternative for Angular or Ember, which it really isn't when you think of it. React is a JavaScript library designed to solve one particular problem, which is rendering UIs and re-rendering them efficiently when there's changes in the world. And it does that really, really well. But it doesn't even attempt to solve many of the other things that Angular and Ember solve, so it's not an interchangeable concept. When you choose React for your application, you choose React and you choose a bunch of other stuff because you still need to do all these other things that Angular and Ember do, such as asynchrony or network connectivity or just code organization and architectural patterns. So you use other libraries for that stuff, or you come up with some of your own. And the thing about that is that to understand this, when you do that, when you combine all of these different libraries, what you end up with is basically a framework. And there was a great article about this by Ryan Florence a few weeks ago, where he basically said that when doing like a substantial front-end development, you can't not have a framework. There's always going to be one, either one you took from the public ones or one that you came up with yourself. And this is what he says. When you decide not to pick a public framework, you will end up with a framework anyway. Your own framework. And you will write the code that glues modules and libraries together, which is something that frameworks do. You will write abstractions when you identify boilerplate, which is also something that frameworks at least attempt to do. So, you'd better go update your Twitter profile because you are now the author of a framework. And this is kind of true, so more or less what you end up with anyway, in every case, is a framework, because there's going to be the code that's essential to your application, and then there's the code that isn't, that you still need to have. That might be someone else's code or your own code, but it's going to be there. And this isn't to say that coming up with your own framework is a bad thing. It might be something you need to do, or a sensible solution, if the existing frameworks don't solve your problem particularly well. And I am drawn by this approach. I very much like the idea of using simple ingredients to come up with this handcrafted framework that solves my problem exactly and doesn't have any excess baggage. But I've tried this a few times as well. The problem just is that I just don't seem to, be able to get there. So what I come up with, I have these simple ingredients, but then I make a mess of them. And somehow it seems that when basically I get the pressure to deliver, there is this thing that happens when my noble intentions are basically undone. And there are at least a couple of conclusions you might make of this. One is that I'm just not made out to be a framework author, that it's just something I'm not good at. But what I like more is to think of it as that the projects that we do are difficult usually. There's deadlines and budgets and customers and changing requirements and users and other problematic things all over the place. And if we don't have to, maybe we shouldn't add this other problem on top of that, which is the task of cultivating our own framework. So, to me, in most cases, it doesn't seem to make sense to reject existing frameworks and try to come up with my own, because it hasn't worked out for me earlier. So then, if you do accept that you're going to have to learn one of these big frameworks, the second strategy then that you can employ is to study that framework. And this probably isn't a huge revelation to anyone, that to learn something you need to study it. But I think there are a few interesting kind of aspects to it that make it something interesting to discuss. One thing is, when talking about frameworks, particularly Angular at the moment, there's this thing that people often say that it's a very difficult framework to learn because there isn't good documentation, or there isn't materials for learning it. That I don't think is really true, at least anymore. There's a huge amount of things on the internet for learning Angular. There's the official documentation, but there's unofficial tutorials, books and screencasts and talks and everything. And all you need to do basically is kind of make your own curriculum out of all of that, which isn't trivial, but it's possible. All the material is there. And the thing is, though, that when you do this, you start learning Angular using all these materials, you end up with on the much talked about Angular learning curve, which is famously visualized by this pen-nable graphic, which explains kind of the experience of picking up Angular, which is kind of a painful experience. And the way it goes is that you're kind of productive with Angular, and then you get stuck, and you realize you actually understand nothing about Angular, and then you basically go down that rabbit hole and emerge 2 days later with a renewed understanding of the framework and a new level of productivity until you get stuck again, and the cycle continues. And this is true with Angular, it is like that. But I would say that it's pretty much true for everything really, everything large that we attempt to learn, like big frameworks or languages or anything. This is how it works. We do something, then we get stuck, and we figure out how to get unstuck, and during the process we'll learn things. It's just the name of the game. And as front-end developers, we know this, since on the web you're kind of always on the learning curve. There's always something new to pick up, and we're never done. But the big kind of issue with being on the learning curve is that usually when you're learning something, you're also doing a project or something. It's usually not that we have endless amounts of time to spend on these things. We need to deliver projects, and we're learning on the job basically. And when during this time we get into this troubleshooting mode, when we do get stuck, it's problematic because it's very likely to blow your schedules. When you end up spending your days on Stack Overflow, it's very difficult to estimate when these roadblocks are going to occur and how often and how long of a time it's going to take to get unstuck. So it's not the greatest thing to happen to have a technology that you're using that you don't fully understand, although that's almost always the case, but it adds this big aspect of uncertainty to our projects. And for me, there's like one even more unpleasant thing about being on the learning curve, which is something that has happened to me, especially with Ruby on Rails. So I've been using Ruby on Rails for about 7 or 8 years now, and I still don't feel like I've mastered Ruby on Rails. Like, whenever I do anything with Rails, I have this feeling that there's probably something I could do that would get rid of half of my code if I just knew about that API or that technique or that gem. So it's not that I'm not productive, it's just that there's this feeling that probably there's something I don't know about that would make me a better Rails developer. And that's happened to me, I think, because the way I've learned Rails is from this patchwork of articles and videos and books over time and first-hand experience, which has given me this partial picture of what Rails actually is, and I don't have a full picture, and I don't think it's possible to ever have that. And that's why you always have this nagging feeling that you could do it better, which is not the best feeling to have. So last year, when I was facing this decision with Angular, I was kind of worried that this might happen now, that Angular would become a second Rails for me. I would spend the next few years basically not understanding it fully and being slightly not being able to use it well. And I was worried that it might happen because people are saying that Angular is difficult to learn and it's big and the documentation is bad and all these things. So then I started to think, well, what can I do to get around this? And one thing related to that is that I started to think, well, who are the actual foremost Angular experts at the moment in the world? And how did they get to be Angular experts? And when you think of Angular experts, pretty soon probably you'll think of someone like Miško. Miško knows Angular, basically. If you can think of any single person that you would take to your Angular team to consult for a day, it would probably be Miško, because he's an Angular expert. And that's because he wrote the damn thing. He's the author of Angular, the framework. So that makes him someone who knows a thing or two about Angular. And so the thing is that Miško knows Angular not only because he wrote the design, but also because he was there at the beginning. Because in 2009, when he came out with the first version of Angular, it wasn't this complicated beast that it is now. It was a much simpler thing, this kind of DOM compilation directive engine. And in the 5 years since then, it has become this big thing that I'm now afraid of. So it wasn't always like that. And Miško didn't arrive at Angular when it was big. He arrived when it was small because he originated with it. And he has been there for every step of the way when Angular has been becoming more complex. So that's how Miško arrived at Angular. And if I set the bar for myself at Miško, like if I want to be as close to that in Angular expertise as I possibly can, then the strategy for trying to be as good as someone else is probably try to imitate them. So this is what people do, or this is what how children pick up things, and both animal and human children. They look at someone do something and they try to do the same after that. So I thought, why don't I try to do what this macaque here is doing with the tongue, which is to try to do what Mishko did with Angular, which was to write it, basically build it. So what if I do this? I start basically building Angular from scratch, starting from nothing, and then step by step, piece by piece, add that complexity in there, so that on every step of the way, I understand what I am adding to the framework, why I'm adding it there, and how it affects what's already in there, and what possibly gets removed while I'm doing that. So that at the end of the process, I end up basically with my own clone of AngularJS. And that's not really because I would need a clone of AngularJS. I don't, because AngularJS is perfectly fine. What I need is the mental model of AngularJS, to have in-depth knowledge of everything that's in there, in that framework, so that I can basically use it as if I was the author and be like that level of expert in Angular. So that's what I set out to do, and that's the build your own Angular process. And the big kind of nice thing about that is that when you've done that, it's no longer scary, because what's scary is the unknown. And when you remove the mystery from something, it's no longer intimidating, because you've taken ownership of that thing. And this a little bit ties also into the first strategy of rejecting big frameworks completely and doing your own, because one of the big benefits you get from building your own framework is that you then know that framework intimately, and you know how to apply it to different situations, and you know how to extend it, which probably isn't the case for the person who inherits the framework from you, but that's another story. But this strategy is kind of like having your cake and eating it too. I get to use AngularJS, but I get to wiggle it as a framework that I had written actually, and know exactly how to use it, when to extend it, and maybe also when not to use it. So that's the idea. Today I am going to attempt to give you a flavor of this process I'm talking about. So I'm going to talk about dependency injection in Angular, partly because it's very interesting, because it's one of those things in Angular that is doing many non-obvious things, and people often say it's overcomplicated and criticize Angular for it, which is partially true. So it is a bit weird, which makes it interesting. And what I'm going to do is, over the next 20 minutes or so, build up a simplified version of the Angular dependency injector from scratch. And if you are an Angular user, hopefully you'll get like a deeper understanding of what the injector is actually doing for you, if you don't already know it intimately. Even if you're not an Angular user, maybe you'll get some ideas for alternative implementations, or just get an idea of this process I'm talking about learning something by construction. So I'm going to use a simple code example here, a simple application into which we will apply dependency injection. And this application is in the domain of our space exploration. So we have a function called launch rocket, which launches a rocket into space, which we simulate by doing a console login statement. So it logs this thing out, and when you call that function, it will just show up on the log there. And then we have a constructor function called bigRedButton, which you can use to make objects, bigRedButton objects, and those are objects that have a few methods on them. Buttons have a lid, which you can open or close, which are methods that just set this Boolean flag on the object. Buttons also have a third method, which is called push. And the push method pushes the button, and that means basically if the button lid is currently open, launching the rocket. And then we have our namespace exploration program function, which will make one of those buttons, open the lid, then push the button, and then close the lid. And when we call that function, we will again see the login statement out there as through the button the rocket is launched. So this is our example application, which we will be exploring. One thing we might want to do with an application like this is to make some of these components a little bit more generic and reusable. So for example, this big red button function that we have, this constructor, is very specialized to do basically only rocket launching at the moment. I think it's easy to think of different use cases for big red buttons because they are quite useful things. So why don't we make the button usable in any context basically, to give the action to it as a constructor argument. And that'll be a function that it will just call when the button is pushed without knowing what it actually does. So here we shift the responsibility of figuring out what the button actually does to whoever constructs the button. The button is now generic. And we could do a similar thing also for the main space program itself. So right now it's constructing a button, but it could also get a button as an argument instead. And again, we shift the responsibility of figuring out what the space program is using the button to someone external. What we've done here is basically dependency injection. So that's all there is to dependency injection really. We have taken stuff from these functions, that the functions we're using, looking up global things or constructing things, and we've taken them out and now we feed them to them as arguments, and that's dependency injection. The components themselves are now more generic. The buttons can be used for more things, and the space program itself can use more buttons. It's just more extensible this way, and that's one of the big ideas of dependency injection. So if your program is as small as this, you of course don't really need a dependency injection framework to help you. But of course there are bigger code bases than this out there. I think some of us have actually seen them. And in those cases, you might want the help of a dependency injection framework to do some of this dependency configuration for you. And then you might want to use something like the injector in Angular to pull some of these components together. So what Angular actually gives you for that is something called an injector object, which you actually usually don't use directly. It's more like baked into the structure of your application, but it is there, and you can use it as a standalone object as well, which we'll be doing here. So we'll create an injector, and then we will let the injector know that some components exist in the world, such as the button here. So we'll tell it that there is something called a button, which is this object here. The simplest way to do that is to use a constant, and that's just saying that just use this value as is, and it will never change, and that's just something you can use when someone needs a button. And once we have done that, we can ask the injector to do dependency injection for us. So what we're doing here is we're saying that, hey injector, please invoke the space program function for me, and also inject its dependencies for me. So when I actually want to call space program, I don't need to know what it needs. It has been configured elsewhere. So this is what our first iteration of the injector will do. And to implement that injector, I'm going to introduce some framework code on the top of the file here to keep it separate from the application code, which is what we have been looking at so far. So we have a function called create injector, which returns an object, which is the injector object. That has two methods on it, constant method and the invoke method. And these are both implemented as local functions here in the closure. The constant function takes a key and a value, and the invoke function takes a function. And so this is the API, but what it should actually do is we should remember what someone has registered using the constant function, and then we should look it up on the invocation, on the moment of invocation, and feed that into the function being invoked. So, to actually have a registry of the components that someone has added, we'll just add a simple object here, a cache object, into which we put things as they are registered. Then to invoke a function is the more challenging part. Like, how do we know, given a function, what dependencies, what arguments it actually needs? Now, if you are an Angular user, you know that there are several ways to do this. You can annotate a function, so especially say that these are the function's dependencies. But maybe the most interesting way to do it is to actually not annotate those at all, but let the injector figure them out on the fly, which is what Angular can do in some situations, and which we'll try to do here as well. And the trick is based on the fact that all JavaScript functions have a method called toString, which gives you the function's source code as a string. That source code will include the argument list of the function. So what we can do with that is, of course, use a regex to extract the argument list. So we can match that string with our regular expression, and we can get a result out of that. So let's try to get the argument list out. So each function source code begins with the word function. Then it's optionally followed by some white space, one or more characters, or 0 or more characters. That's followed by the function name, which we'll define as a succession of characters other than the opening parenthesis, like that. Then we can match the actual opening parenthesis, and here begins the actual argument list, which we define as a succession of characters other than the closing parenthesis. And then finally we'll match the closing parenthesis itself. And what that gives us is a match result where the function signature has been matched. What we are interested in actually is the argument list there only. So what we will do is take that part from the regular expression, which goes between the parentheses, and put it in a capturing loop. And what that does is it gives us the argument list as the second item in the match result here. And there we have the argument names. And we still need to split it at the comma to get, because there might be multiple argument names. And that gives us the array of argument names of a function. Now this is, why people criticize Angular, basically. This is really weird how this works, and to be fair, they are removing it in Angular 2 and even Angular 1.3, which is coming out any day now. They have this new so-called strict mode, which doesn't let you use this style of dependency injection. And because it breaks under minification, and there are all kinds of issues with it. But it's interesting. And it's what most of us use when we start out with Angular, because it's all in all the tutorials, and it's the most simple way to get started with, although it's a bit too magical for my taste. But now that we have this code, we can pull this into our framework code, where we have this function, and we can take its arguments by first extracting the argument string, and then mapping, splitting it at the comma, and then still mapping that so that from each argument name we will remove all white space, because there might be white space between the commas. So we'll use a replace function method call to replace any white space in each argument with an empty string to remove it. And here we have the array of argument names of the function. And then we need to get the actual arguments, which we can do by, again, mapping over the argument names and just looking each of them up from the cache that we set up earlier. And there we have the arguments we should call the function with. And we can do that by simply applying the function to those arguments. And here's how we can call a function with dependency injection by also looking up the arguments dynamically from the function source code. And that passes the first requirements of our injector, which is doing constant and invocation. Now that we have the injector, we can also ask it to do more work for us. So, for example, we're still having to maintain this dependency between the decrypt button and the launch rocket manually. The injector can do that for us. So, if we define the button as, instead of a constant, as a factory, it will give us more possibilities for configuring it. So if you have a button which is defined as a factory, that's going to be a function that returns the actual dependency instance, like this. So at this point, these two ways of making the button are more or less interchangeable, but we can see more of the difference when we actually think of what we might need for constructing that button. So the button action is something that the injector could actually give us. So if we have that defined, we can inject it to the factory. And this is something you can't do with constants. You can't inject things to them. But now we can, and we've basically broken the dependency between the decrypt button construction and the launch rocket function. Now we no longer need to know that explicitly because it's configured elsewhere. So that's basically factory, and to implement that, we'll need to introduce a new method to the injector. That goes to the public API over here, and then into this private function where we actually implement it. And the factory takes a key and the factory function, and then we need to do stuff. But what should we actually do? The cache we have here, we can't really put the factory function in the cache because the cache is for the final dependencies, not the factories that make them. But we also can't really call the factory yet at this point, because if you look at the application code, the button action doesn't yet exist when we register the factory for button. This is one of the big things that Angular buys you. You don't need to load your code in the order of the dependency graph. You can load things that depend on something else, even though those dependencies haven't been loaded yet. And that's good for application developers. But as we are now framework authors, we need to do a bit of work to make that happen. So what we'll need to do is keep the factory function around for invoking it later. And now we'll have actually two caches here in our injector. One is for providers, such as factories, and one is for the actual instances. The constant we'll put in the instance cache, and the provider or the factory function goes into the provider cache. So two different caches for two different kinds of things. And where we now use these things is during the dependency lookup. So as we have the argument name or the dependency name, we will first see in the instance cache if it has what we need. And if it does, we can just return it, which is the use case we had earlier. If it isn't there, we will look into the provider cache. And if that has the dependency, it's not going to be the dependency itself, but the factory function we can use to produce it, which we'll call provider here. And that's going to be a function which we need to call with dependency injection to produce the instance. And for that, we actually have already the tool we need, which is invoke. So we have here a recursive invocation of the invoke function to get transitive dependencies. So factories might have other factories as dependencies, and you can go very deep with your dependency graphs because they can resolve themselves recursively. And that's the instance, we can just return it. But there's one more thing we're going to do, which is that if you know Angular, you'll know that in the dependency injection framework, everything is basically a singleton. So when we use the same dependency in two different places, it's always going to be the same exact object. And that's made possible by this code here, which actually puts the instance to the instance cache when it's constructed. So the next time someone needs the same thing, it'll be in the instance cache. And we will never actually call the same provider or factory function twice. And that's the factory implementation. So we can now do constants and factories and function invocation with our injector. And there's one more thing I'll show, which is kind of the next level of abstraction, which is that also related to this big red button here.